If we are to consider what we had from our previous exercise, we were working with the theorems that are actually our theorem number 1. And I asked you guys to go and look into this question so that we can have a revision together. So I just hope we did so that it can be of advantage in our revisions. Remember, I was talking about this theorem or theorem number 1, that if a line is being drawn from the center of a circle, all right, and is perpendicular to a chord, like what we are given on these two conditions, we are going to see that these two chords are going to be divided into two equal parts. So meaning to say, on this chord RS, RP is going to be equal to PS, TV is going to be equal to VU. That is the condition of our theorem. Remember our first theorem. So on this question number 2, we were given if RS is equal to 48 units, OP 7 units, and TU 40 units, determine the radius of the circle, determine the length of OV. All right, let's take into consideration what we are given. From R to S, that is from R to S, it is 48 units. The whole of this line, RS, is 48 units. So what does it mean? Remember what I was explaining before, that in this consideration, all right, so we're going to start with 2.11. Let us just take our information on the diagram and see. So if you're to consider this, the whole of the line RS is the one that we are given as 48 units. And we understand that if a line is being drawn from the center perpendicular to that chord, it is simply bisecting that chord into two equal parts. That is meaning to say that in this case, we are going to notice that this OP that we have is bisected RP and PS. So at the end of the day, we are going to have RP being equal to PS, from R to P and from P to S. Remember, they are equal. So we can divide this RP, PS, we can just divide 48 divided by 2, which is going to be 24 units. So it means on RP here, I've got 24. On PS, I've got 24. This is what I'm having. And OP is given as 7 units. From point O to P, this is given as 7 units. This is what we have. TU is 40 units. From T to U is 40 units. If we do the same thing, that means we've got equal length from T to V and from V to U. So if you're to divide 40 divided by 2, it was going to be 20. So that means this TV was going to be 20. This VU was going to be 20. But where is it playing a role in determining the radius of the circle? What is the radius of the circle? The radius of the circle is the line that is drawn from the center of the circle to the circumference of the circle. From the center of the circle to the from the center to the circumference, center to the circumference. So it simply means OT is the radius, OU is the radius, OS is the radius, OR is the radius, as long it is drawn from the center of the circle to the circumference. So if you were to take that into consideration, you're going to see that on this side, ORPS, this side, if we were to complete this from O to S like this, or from O to R like this, we are formulating what? That's the radius. O to S is a radius. O to R is a radius. So it simply depends which part are you going to work with. Remember, OP is it's a line that is bisecting this line RS, and it's what? It's at 90 degrees. So meaning to say I can work with this triangle to calculate OS, which is the radius. I can work with this triangle to calculate OR, which is the radius. So what I'm simply saying, you use whatever triangle that you want. So using triangle OPS, or from triangle OPS. So if you are to take a closer look in this case, this is a right angle triangle that you are formulating on that triangle OPS concept. You are formulating a right angle triangle like this. This is your O, this is your P, this is your S, where this is 90 degrees. Remember, PS from P to S is 24 units. From O to P, we are given this is 7. So you can calculate OS, because OS is the radius. OS is the radius, same as OR is the radius. So by calculating the radius, we are calculating what? OS. And how are we going to calculate OS? Using the Pythagoras theorem. Why? This is a right angle triangle that we are given. So we can use our Pythagoras theorem. C squared is equal to A squared plus B squared, whereby C squared is the hypotenuse that we are given, OS, the one that is opposite to the what? To the 90 degrees, the one that faces the 90-degree angle. So that's OS squared is equal to AB and B. A and the B, these are the shorter sides, the sides that are remaining, the 7 and the 24. So it's 7 squared plus 24 squared. So that is going to be the formula that you are supposed to use there. OS squared is equal to, in this case, we can even simplify direct on your calculator, or you can simplify stage by stage. That was going to be 49 plus 576 for 24 squared. Then if we add these two, we're going to obtain 625. So how do you remove the square that is on OS, this one? To remove this, you are going to introduce the square root on both sides. So that means OS is going to be the square root of 625, which is 25 units. So that was going to be the OS, and OS represent the what? The radius. So therefore, our radius is equal to 25 units. So that is the case of our question. So it is the same thing that you're supposed to obtain even if you're to use this triangle, this one. Apply the same concept. You see there's a 7, there's a 24. So it's just a repetition. We are going to see that this is the same thing that you're going to have at the end. All right. Number 2.12, we are now given, in this case, this is 2.12, to calculate or to determine the length of OV from O to V, this one. What will be the length of OV? All right. So just like the previous case, if you are to check on this side, we are given the length of OP, but this side we are not given the length of OV. But remember what I explained before, that from O to U, this part, from O to T, this part, it is also the radius of the circle. So we can take advantage of that using a right angle triangle. Maybe I'm going to use this one, or I'm going to use this one. It's up to you. All right. So in this case, we were going to use, let us just use OVU. All right. Remember, we want to calculate what? Calculate OV. All right. So to calculate OV, what are we going to do in this case? All right. So like I said, using or from triangle, you're going to take triangle OVU. Whatever part that you take OVT is the same thing. They are concurrent triangles, those ones. All right. So OVU. So using triangle OVU from O to V to U, it's a right angle triangle, which as we can see, it's a right angle triangle, that one. All right. And we have got OU, which is the radius, just like I mentioned before, from the center to the circumference. So OU is the radius, and we calculated the radius of the circle, which is OS. The radius is 25 units. So it means OU is also 25 units. This is 25 units. So you're formulating a triangle like this, from O to V, from O to V, then from V to U, like this. You're formulating a right angle triangle. This is exactly what is happening on our diagram. This is exactly what we have there, where O view this one, the OU is the radius, and we have that length of the radius, which is 25. OV is the one that we need to calculate. We do not know this, but we have V to U. Remember, from V to U, you were given the whole of this line TU, where you divide it by 2 because it is a perpendicular bisector. It bisects this line into 2 equal parts. So that was a 20 there. So using this information, again, we are back to the Pythagoras theorem, where we can calculate the missing side when given two sides of a right-angled triangle. So from C squared is equal to A squared plus B squared. What is the hypotenuse? The hypotenuse is 25. So 25 squared is equal to A and B. These are the shorter sides, which we can take our OV, the side to be calculated, plus B, which is the other side, that is going to be 20 squared. So depending on the way that you're going to calculate this, I can even transpose this 20 squared on the other side. So it can be 25 squared minus 20 squared is equal to OV squared. I want to calculate OV, so I can simply introduce the square root both sides. By introducing the square root, I'm simply canceling this. The square root and the square neutralizes, remember guys, from grade 9 actually. All right. So this is going to be OV, which is equal to, you can simplify this direct on your calculator so that you have got exact values on that part. So this was going to give us 15 units. All right, so this is what I'm trying to say. If you're given a condition like this, you can also take advantage of your calculator, the square root of 25 squared minus 20 squared, like this. All right, minus 20 squared, like this. So this is going to be 15 units. So that is, we've already inserted the square root. So it determines everything on that part. So OV at the end was going to be 15 units. So that is the idea there. You see the theorem of the line drawn from the center of a circle perpendicular to the chord, bisecting a line, which is bisecting that chord. It is very, very important because that made us to know that this is 20 and this is also 20. And by that, OU, we know that is a radius from the center to the circumference of the circle, or to the circle. You have what? You've got the radius there. Using your Pythagoras theorem, because you formulated a right angle triangle, you can calculate the length of OV. So that was the condition of your question. So now they gave us a certain information which is actually different from what we have. If OP is this, as you can see, we were given this information before. So this time is something else. I'm just going to remove this. Like, we do not have that exactly. Like, it's a startup person. So it's going to be difficult, especially if you are those guys who mark on the diagram, because this one, everything was new, which is something that you're supposed to have an extra diagram for that if it is to happen in exam, but they won't do that. You know that. All right. Anyways, let us see. We are given in this case, if OP is another situation now, if OP is 16 units, so from O to P this time is 16, OV is 25. This time we are given OV. Remember last time it is us who calculated this OV, but this time we are given the OV as 25 units. The center has a radius of 65 units, and the circle has a radius of 65 units. So what does it mean? The radius from O to R, so it means from O to R, from O to S, this is our radius, which means from O to T, that's our radius. From O to U, that's your radius. All this, it is equal to 65 units. Show that the sum of the chords is 245 units. Show that. So what are we supposed to show? The sum of the chords. And what are the chords? The chords is RS, that is from this one, the first chord. So if you add RS and the other chord, which is TU or UT, if you add these two, we must obtain 246 units. That is what the question is asking us there. The sum of the chords, this chord plus this chord added together gives us 246 units. So the question is how? How is that possible? How is it possible? All right, let us start from the basic units that we had before. Remember previously, I said that from O to S, it is the radius of the circle. Remember that? And this is what we are given, OS, OT, whatever that you're given, this is 65 units. So it means I have got a 60. I'm just going to maintain this triangle that I used before so that we do not confuse each other here. This is a right angle triangle. So it means if I am given OP, given also OS, I can be able to calculate the length of PS. It's possible to calculate PS because this is a right angle triangle, remember? So it means you can be able to calculate PS. So from triangle OPS, all right? Why calculating PS? Because we know that PS is equal to RP. So if I have PS, it means I have RP. And at the end of the day, I have got RS. RS is simply the product of 2 times PS or PS plus RP. That is what it simply means there. So if I can calculate PS, I'm done. Which is the same way that you could have done if you're using this triangle, this side, you calculate RP. By calculating RP, you are done because RP is equal to PS from that theorem. So how are we going to calculate PS? It's a right angle triangle that is being formulated in this case from O to P then to S, we are formulating a right angle triangle, just like the previous case. This or P, this or O, this or S. And we want to calculate PS, given that this is 65 and this is 16 units, and we want to calculate this side on this triangle. So meaning to say we can use our Pythagoras theorem to calculate the third side, which is PS. All right, from our C squared is equal to A squared plus B squared. It follows that C is the hypotenuse, which is the one that faces the 90 degrees, which is the 65. So thus 65 squared is equal to A squared plus B squared. These are the shorter sides that you're given, 16 squared plus another shorter size on this side, which is PS. So this is PS squared. 65 squared, we are going to obtain whatever value that we have, or like I said previously, you can simply transpose this to the other side so that it becomes a negative. So it is going to be 65 squared. Remember, we transposed this, so it's going to be 65 squared minus 16 squared, which is equal to PS squared. So how are we going to obtain PS? We simply introduce the square root on this case. All right, so that was going to give us the length of PS. And this was going to give us 63 units if you simplify properly from your calculator, just like the previous case, guys. All right. So having our PS being equal to 63 units, what is the advantage of calculating PS? So like I said before, if we know that PS is 63, it also means RP is also 63. That means we've got the length of RS. Remember, what we need is to show this RS, the length of the card. So RS is the product of 2 and what? And 63, or simply 63 plus 63, because that is the line segment concept. All right. So we can have RS at the end here. So that simply means RS is 2 times 63. Remember, that is RS is half of what? Half of the whole chord that we are given. So that is that was going to give us 126 units. That is RS. We are not done because we need the sum of the chords. Show that the sum, if you add the two chords, you must obtain 246. The first chord we calculated RS. We need to calculate the chord TU, which is the second chord from T to U. So using the same concept, we are going to have, remember, this is 25 from O to V. And I said also OU is the radius. From O to U is the radius of the circle. So in this case, let us calculate. So we're just going to say calculate. The first thing, going to calculate VU. All right, so we're going to calculate VU using this right angle. As you can see, we are having a right angle triangle like this. We are having a right angle triangle. This is O, this is V, this is U, and we have O to V. This time we were given from O to V, it is 25 units, and we want to calculate this VU, given that OU is the radius. OU is the radius, and it is what? 65. So this is 65. So again, Pythagoras theorem can be used to calculate this VU. Remember, C squared is equal to A squared plus B squared, and the hypotenuse there, the one opposite to the 90 degrees, there is 65. So that's 65 squared is A and B squared, which are the shorter sides. So we've got 25 squared plus VU squared, which is the one that we want to calculate. Transposing the 25 to the left-hand side, we are going to subtract that. It was a positive. So it's 65 squared minus 25 squared is VU squared. So how now am I going to calculate the value of VU? So I'm just going to introduce the square root on both sides. So that means I have got the length of VU in that case. So this is it, guys, and your calculator, just like I explained before. So let me just bring it again just for the sake of revision. So this is it, your square root there. So you're going to have 65 squared minus 25 squared, and that was going to give us a 60. So this is 60. That means VU is equal to 60 units. That is our VU 60 units, like that. All right. So with the same simplification that we are given here, VU, that is this one, from V to U, this one from V to U is 60. And also remember, I said these two are equal from V to U and from V to T, a line drawn from the center perpendicular to the chord, bisects the chord, divides the chord into 2 equal parts. So it also means this is 60. So that's why we've got TU in that case. All right. So TU is going to be 60 times 2 or 60 plus 60. That is your TU in that case. So therefore, our TU at the end was going to be 2 times 60 units, which was going to be 120 units. So what is the purpose of calculating this? Like I said, remember, we are being asked to show that the sum of the two given chords should give us 120. So let us add RS plus TU, which is the sum of the chords. The first chord, RS, it gave us 126 plus the second chord, TU, it gave us 120 units. So by adding these two, we are obtaining 246 units. That is the case. So this was going to give you a 246 units. So this is how the question just wanted to be applied. They wanted you to go back to your Pythagoras theorem again. Use the concept. What is it that you are having there? What is it that you are having on that exercise? All right. So these are the typical questions that you're going to have in your revisions. So make sure that you do so to watch all of the classes and also the question papers that you are going to have as a revision so that you cater up for your revisions. But for now, that's it till we meet again.